Hello everyone and welcome to this product demo. My name is Nathalie Deguin, I'm Sales Manager at Parifex and I'm here today to share with you our vision about smart infrastructure and how smart sensors can be a great help for cities of tomorrow. So I'm going to present you today our innovative sensor based on 3D LiDAR technology, and what I really want to do is for you to see all the great potential this technology has to offer and what it could bring to smart cities and in our day-to-day life. I have some great material to show you, don't worry, I'm going to try keeping this presentation as dynamic as possible. Few words about us. Among other activities in engineering, we actually are one of the main providers of speed enforcement systems for the French government. And yes, I'm trying very hard to hide my accent, but you may have guessed now that we are a French company. We've been in the field for more than 25 years now, with experts in video analytics, IT development, AI, image processing, and actually all the development that we've done to improve the performance of our systems led us to create a third division dedicated to smart city matters. You'll understand why after. Parifex, it's 16 million euros of turnover, 60 employees and more than 400 speed traps deployed as for now. The good news is that this figure will increase soon. Well, the good news for us. We have been awarded a new contract starting next year for the supply of about 1,000 multi-violation control systems. And then a few words about our product range before I go right into today's topic. We have a range of several systems, stationary or mobile, with various functionalities: multi-lane control, speed enforcement obviously, vehicle identification, vehicle classification, double-side interception, but I will focus today on the NanoCam. The NanoCam is like a multi-toolbox. It can be used as a mobile enforcement system on a tripod. It can be used integrated in other systems as main measurement tool, or it can be used as traffic data collection tool. Traffic data collection is a major subject today because we cannot ignore anymore the issues of urban congestion. Let's start from a fact. The population in cities is growing. It is expected that by 2050 we'll reach 6.5 billion of urban dwellers worldwide. And that's a fact. That would mean 50 cities hosting more than 50 million inhabitants. More people in the same restricted area means automatically more urban congestion. And what comes next? Traffic jam, pollution, accident, stress, etc. It obviously has an economic and ecological cost. As an example, in France, the cost of road congestion is estimated at 17 billion euros per year. So the big challenge for smart cities today is to optimize the urban travel flows. But how? By improving transport system, for instance? That would be a start. And how can you improve transport system? Starting by understanding what's going on. And how? By collecting real-time traffic data. And that finally brings us into today's topic. We at Parifex believe that 3D LiDAR technology is a great way to collect the most precise data in real time. For those of you who are not familiar with this technology, let me just explain quickly. Basically, it's layers of laser beams rotating at 360 degrees, retrieving a point cloud, each point with Cartesian and polar coordinate, allowing a 3D modeling of the environment in real time. Picture speaks better for themselves. Let me just show you an example. On your left, you have the camera view. On the right, the LiDAR's view. The camera view is just for you to be able to compare the information retrieved by the LiDAR in real time. In this case, we are using a 32-beam LiDAR from Velodyne. As you can see, we can clearly see the lanes, we can clearly see the shape of the road, we can see the trees, we can see the vehicles driving by, we can see the signs. It's very precise. It's a very powerful technology used a lot for mapping, for instance, and we figured we could use it in our own application. I will now explain how and why. Using the 3D LiDAR, we have developed our own system called the Nano. Thanks to our own algorithm, we can detect any moving targets in its field of view. For each target, we gather precise information such as the precise position of the object, its direction, its speed, its dimensions, from which we deduct the category of vehicle. We also have the precise timing, etc. So with all this information in our hands, we figured it can be useful for many applications. One of the applications, for instance, could be traffic counting, traffic management. On the left, you have a bird view of the LiDAR, and you can see the vehicle being counted. On the right, you'll see all the kind of information we can gather and retrieve, so you can have some statistic reports on traffic data, all this in real time. So you can have the flow rate, you can have the occupation rate, the average speed, you can see all the different categories of vehicle, and all this information can be seen either live, or you can pick a certain time slot and have some statistic reports. Then we have speed enforcement, obviously. It's actually where it all started for us, because the Nano was actually developed at first to improve the performance of our system. So the system is already in operation as it's integrated in our own speed traps, and it's certified for vehicle identification and vehicle classification. Now, another application that I wanted to share with you is for autonomous vehicle project. That's another big subject nowadays, as you know. We at Perifex have been participating in big projects for Transdev, for instance, where they use our sensors installed in the infrastructure. The idea is to use our sensors to improve the vehicle environmental perception and support the autonomous vehicle in making a better risk analysis to navigate the roundabout. Concretely, what does it mean? In roundabouts, you often have blind spots. Could be work of art, trees, etc. With our sensors, we detect all the moving objects and communicate the information to the autonomous vehicle. Could be a pedestrian crossing, someone arriving too quickly, and the autonomous vehicle would adapt its navigation accordingly. Let me show you how it looks. On the left, you have the LiDAR view. It's a bird view. And on the right, again, you have a camera view so that you can compare the information coming up. As you can see, we detect all the cars driving by, and we had an ID to this object. So we can track it, we can follow it. We have the classification, so we know it's a car. And here is coming a pedestrian. So you don't see it on the camera because the field of view is not the same, but it's going to be appearing right now. So that's basically how it looks, and that's how we can gather all this information. Now I'm sure you wonder why the LiDAR and not other technology. As you can see, the LiDAR offers many advantages compared to Doppler or camera. The accuracy, the precision, the field of view, the range, the fact that it works in any weather condition, it's not affected by light, works the same way whether it's day or night, and combined with our algorithm that give us a very high accuracy in object detection, object counting, positioning and tracking, classification, etc. Now I'm sure you know this video also has its plus. The good news is we also know how to use it. Indeed, combining LiDAR technology with camera using AI and image processing techniques gives us this very powerful system able to monitor so many violations, so many situations. For instance, red light enforcement, speed, stop signs, reserved lanes. We can monitor pedestrian priorities, tailgating, seatbelt use, phone use. We could also monitor low emission zone, wrong way driving, safety distance, and thanks to our own integrated ANPR, we have all the information we might need. So this is very interesting to combine this information, and knowing that, we do realize that there are many applications possible and many needs that could be fulfilled. Let me show you some examples. Here we have the stop identification functionality, for instance. So we use the camera to detect the stop signs, and we still use the LiDAR to detect, track, and identify the vehicle. And here's another example of red light identification using the combination of camera and LiDAR for vehicle identification and vehicle tracking. So I hope I gave you an idea of all the potential that this technology combined with our software can offer. Once you know all the information we can collect in real time, the possibilities are endless. It can be used, as I said, to help autonomous vehicles, for instance. It can be for traffic management if you want very precise traffic data. It could be for traffic regulation if you want to restrict certain areas like low emission zones. It could be for smart parking. It could be for detection of offenses or behavior related offenses. Basically, everything is possible. So all we need now is to hear from you what problematics you have and how we can help. So I'm gonna stop there. Thanks a lot for listening to me. I hope you enjoyed the presentation. Please do not hesitate to contact me if you have any question. I'll be more than happy to have a chat with you. Take care.